Hey there, amazing people. I'm thrilled to have you here today. Welcome to our channel, where today's focus is all about Bessel polynomials. Let's get started. In mathematics, the Bessel polynomials are an orthogonal sequence of polynomials. There are a number of different but closely related definitions. The definition favored by mathematicians is given by the series frac left frac right. Another definition, favored by electrical engineers, is sometimes known as the reverse Bessel polynomials. The coefficients of the second definition are the same as the first but in reverse order. For example, the third-degree Bessel polynomial is x1, while the third-degree reverse Bessel polynomial is x15. The reverse Bessel polynomial is used in the design of Bessel electronic filters. Get ready to immerse yourself in the world of definition in terms of Bessel functions as we examine its impact and relevance. The Bessel polynomial may also be defined using Bessel functions from which the polynomial draws its name. Ynex frac frac 1x. Phaetonx frac pi and frac 1x. Where knex is a modified Bessel function of the second kind, ynex is the ordinary polynomial, and nex is the reverse polynomial. For example, yxxx frac frac 1x. Now, let's shift our perspective and explore definition as a hypergeometric function from a different angle. The Bessel polynomial may also be defined as a confluent hypergeometric function. Ynexa, fn, left frac tuxite n ulift n, and frac tuxite left frac tuxite n ulift n and frac tuxite. A similar expression holds true for the generalized Bessel polynomials, see below. Ynaxob, fnna 1, xaber left frac bxritna uliftna erna frac bxrit. The reverse Bessel polynomial may be defined as a generalized Lagrange polynomial. Phaetonxa frac ernal nnax, from which it follows that it may also be defined as a hypergeometric function. Phaetonxa frac n ern of n anax, where n is the Pochhammer symbol rising factorial. Brace yourself for an in-depth analysis as we navigate through generating function and its far-reaching implications. The Bessel polynomials, with index shifted, have the generating function summa 9 fisa frac a pike san frac 1 xk n frac 1 x fracitan and ig summa 9 theta nx fractan and exert it differentiating with respect to t, cancelling x, yields the generating function for the polynomials nn0. Summa 9 theta anx fractan and frac assert it I assert it. Similar generating function exists for the yn polynomials as well. Summa 9 yn x fractan and x frac cert x right. Upon setting t x, one has the following representation for the exponential function, i.e. summa 9 yn x frac xernan. Turning our focus to recursion, let's explore its key elements. The Bessel polynomial may also be defined by a recursion formula. x1, xx1, ynex and xynx, and x1, xx1, x and nx. With our curiosity piqued, let's embark on a dedicated exploration of differential equation and its fascinating intricacies. The Bessel polynomial obeys the following differential equation: xa frac and x frac theta nexa xn frac theta nexa xerna theta nexa. Moving on to the next segment, we have orthogonality. The Bessel polynomials are orthogonal with respect to the weight ex integrated over the unit circle of the complex plane. In other words, if nm is 0. In the next segment, we'll be exploring explicit form and its implications for our subject matter. A generalization of the Bessel polynomials have been suggested in literature as following. y x alpha beta n left frac x beta right and L n1 and alpha left frac beta x right. The corresponding reverse polynomials are theta x alpha beta frac a beta null n1 and alpha beta x and y left frac 1 x alpha beta right. The explicit coefficients of the y-x polynomials are y-x alpha beta summe kern binom and alpha underline ker left frac ser beta right. Consequently, the next polynomials can explicitly be written as follows. Theta x alpha beta summe kern binom and can alpha underline frac ker beta and k. For the weighting function, r alpha beta f left alpha 1, frac beta x right, they are orthogonal. For the relation 0 x, in x, in x, x holds for meters n and c a curve surrounding the 0 point. They specialize to the Bessel polynomials for equal to, in which situation x equal x. Prepare yourself for an in-depth analysis of Rodriguez formula for Bessel polynomials in this section. The Rodriguez formula for the Bessel polynomials as particular solutions of the above differential equation is in alpha beta x frac and alpha beta x psi alpha eta frac beta x left frac x right and psi alpha and eta frac beta x, where are our normalization coefficients. Now, let's shift our perspective and explore associated Bessel polynomials from a different angle. According to this generalization, we have the following generalized differential equation for associated Bessel polynomials. X frac m alpha beta x x frac m alpha beta x x left b m alpha beta x, where 0 m n the solutions are m alpha beta x frac m alpha beta x psi alpha eta frac beta x left frac x right and m psi alpha and eta frac beta x. As we transition to the next segment, let's unravel the mysteries surrounding zeros and gain a fresh perspective. If one denotes the zeros of y-x as kern, and that of the next, I kern, then the following estimates exist. I frac an alpha early alpha can alpha left frac an alpha and I frac an alpha early beta can alpha left frac an alpha for all 2. Moreover, all these zeros have negative real part. Sharper results can be said if one resorts to more powerful theorems regarding the estimates of zeros of polynomials, more concretely, the parabola theorem of Sarf and Varga, or differential equations techniques. One result is the following. I frac an alpha frac early alpha can alpha left frac an alpha. Now, we shift our focus to particular values, a topic that deserves our attention. The Bessel polynomials y-x up to n5 are a beginnerline y-x and equal x plus 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 y-x and equal x enderline. No Bessel polynomial can be factored into lower degree polynomials with rational coefficients. The reverse Bessel polynomials are obtained by reversing the coefficients. Equivalently, Cox-Circi kex. This results in the following. A beginnerline theta x and equal theta x and equal x plus theta x and equal x plus 3x plus theta x and equal x plus 6x plus 15x plus theta x and equal x plus 10x plus 45x plus 105x plus theta x and equal x plus 15x plus 105x plus 420x plus 945x plus enderline. Don't forget to hit that notification bell so you never miss an update from my channel.